Hello everyone. In this lecture video, I am going to try and solve a few problems which are usually asked on MOSFETs. These questions are related to the threshold voltage of the MOSFET, which is Vth. And for simplicity, I am assuming that the Vth of MOSFETs are 1 volt. Okay. And I am putting it under the mod sign, considering both PMOS and NMOS. Okay, the question can be like this. Let me draw a few examples. Let's say that I have a NMOS, and let's say that it is connected to another NMOS in this series manner. Now in this questions you will be given voltages at the gate and one of the terminals. Let's say that the VDD is 5 volts for all our examples, and as I told you, let us just assume that the threshold voltage is 1 volt, and let that be in mod sign. Now let me just solve this first problem, where let's say that this gate voltage is 5 volts, and let's say this gate voltage is let's say 4 volts, and the voltage which is applied here, let's say that is also 5 volts. Now you have to find out what is the voltage at this particular node. Okay, what is the voltage at this particular point? So these are commonly asked questions, and it's a very simple question, and we can solve it by knowing a fact that the MOSFET gets turned on if it has a voltage of Vth between its gate and source. Now first let us properly define the threshold voltage for a NMOS. For a NMOS, the threshold voltage is the voltage between the gate and the source, such that it is greater than or equal to the threshold voltage. So in our case, the gate to source voltage must be greater than or equal to 1 volt. The gate to source voltage means that the gate voltage minus the source voltage. So that must be greater than or equal to 1 volt. So any voltage between gate and source which is lesser than 1 volt, your MOSFET is off, and when it is off, there is no current between the drain and source. So that's it. We can solve this question now easily. Now for this, another thing, this is the first point, and another point is we must always consider the drain, the source, and the gates as capacitors. Okay, we must consider them as the capacitors. Either it can be gate or drain or source. Initially you consider them as capacitors, and if the node voltages is not given, consider that as a capacitor which is uncharged. So what do you mean by uncharged? By uncharged I mean consider them as a capacitor whose voltage is 0. It means there are no charges on the capacitor plates. So let us get started and solve this interesting problem. Okay, let me just use green colors to show the capacitors. Now, as I told you, we must consider the drain, the source, and gate all as capacitors. It means I can, there is a capacitor over here, and there is a capacitor over here. We must just consider them as capacitors. And initially, let's say that they are uncharged. That is, the voltage across them is 0 volts. Both of them. 0 volts is the voltage. That is the initial condition. Okay. Now first let us check what is the VGS voltage for the first MOSFET over here. Clearly this is the gate, and which is the source. This is another point. Let me just change colors. This is the gate, that is very clear, but which is the source? This terminal on the left or this terminal on the right? This is another point where usually people get stuck. Source for a NMOS source is any terminal where the voltage is lesser. Okay. For example, here in this case we have considered this node to be tied to 0 volts. So this must be treated as a source. Because this is the source, the other terminal by default can be treated as a drain. So what is this gate to source voltage? The gate to source voltage is the voltage between these two terminals. So what is the initial voltage between gate and source? Let us do that. The gate voltage minus of source voltage. Now for the first MOSFET, the gate voltage is 5 volts minus what is the source voltage initially at? It is initially at 0 volts. So the gate to source voltage is 5 volts. It means this MOSFET is on. So first MOSFET is in on condition. Very good. So that means there is a current flow between the drain and source. So what happens if the current flow? If the current flows, there will be charges which will be put on this capacitor and voltage will start rising. It will start rising, and what happens when it rises? The source voltage will increase. What will happen to the gate to source voltage? This entire voltage, it will reduce. That means your MOSFET is going to be off at one point of time. So let us see what is that point. Let's say now that this point charges all the way up to 4 volts. Now once you have 4 volts across this capacitor, what is the gate to source voltage again? The gate to source voltage is again at 5, but source voltage is 4. That gives me 1 volt. So what is this 1 volt? 1 volt is my threshold voltage. It means the moment this capacitor gets charged to 4 volts, that is the critical point. There cannot be any current which can flow between drain to source beyond this point. The other way to look at this is, if the source voltage is greater than 4 volts, let's say that, just as an example, okay, this cannot happen in reality because MOSFET gets turned off, but let's say that your MOSFET, this capacitor charges to, let's say 4.5 volts, okay. So gate voltage minus source voltage, if it charges to 4.5 volts, then you have gate to source voltage as 0.5, which is lesser than 1 volt. It means your MOSFET is off. If the MOSFET is off, there cannot be any current. Okay, so this case cannot happen because MOSFET cannot be on such that you charge it up to 4.5. So the maximum voltage to which you can charge here is 4 volts. Okay, so we got that at this point can charge only up to 4 volts because at 4 volts the gate to source voltage will become 1 volt, which is the minimum voltage to keep the MOSFET on. Okay, now let us consider this second MOSFET over here. Okay, now we know that this node voltage is 4 volts. We have found out, and now this node is initially it is at 0 volts. So this becomes our source. So this is our gate. So what is the gate to source voltage for our second MOSFET? Gate voltage minus source voltage, that is 4 volts minus of 0 volts, which is 4 volts. Very good. It is greater than 1 volt, so the MOSFET is on. So what is the, going by the analogy which we just spoke about, what do you think is the maximum voltage which can appear here such that the MOSFET is still on? What is that number value? The value is 3 volts, correct? So because if the source voltage, that is gate voltage minus of 3 volts, that gives me 1 volt, which is the threshold voltage. It means this node can charge only up to 3, because the moment the source charges to 3 volts, the gate to source voltage becomes 1 volt, and beyond this the MOSFET cannot conduct. So what will happen here? This can charge all the way up to 3 volts. So what is the answer for this? I just created a mess on this page. So this node voltage can be a maximum of 3 volts. And what about this node? Let me just show it at this point. This can this can be 4 volts. So that's it. This is how we can solve. And maybe we can solve some more questions in the next lecture video maybe.